In this lesson, we're going to talk a little bit about the properties of ionic compounds. So again, an ionic compound is formed by the transferring of valence electrons between the positively charged cation and the negatively charged anion. What ends up happening when they form is something called a crystal lattice. And in this crystal lattice, what we have is we have very, very tightly packed positive charges surrounded by negative charges. And so in this picture over here at the left, what we have is everywhere we have sodium, that's a purple ball. And each of these purple balls is completely surrounded by one of these yellow balls. And they're in a very tightly packed, organized, repeating pattern. And this is your crystal lattice. This is a very, very stable structure. It's very ordered, it's very regimented, and it's very hard to break apart. Some of the properties associated with these ionic compounds that form these crystal lattices are very high melting and boiling points and a high relative hardness. These are due to the fact that we have a very organized and rigid structure. Now, the electrical conductivity thing is a different idea. The picture down here at the bottom, the first picture, the one on the left, shows pure distilled water. And distilled water will not conduct electricity. If you then place the electrodes of that light bulb into pure salt in the crystal lattice form, it will also not conduct electricity. When an ionic compound will conduct electricity is when it's dissolved in water. Okay, and that makes these things called electrolytes. You've probably heard that term before in reference to like Gatorade or Powerade, something like that. Now these electrolytes occur when it's in something called an aqueous solution. An electrolyte would be an ionic compound dissolved in water to form what's called an aqueous solution. In addition to the properties already mentioned, ionic compounds, when they form, always occur one of two ways. The first way is when heat or energy is absorbed. Energy is absorbed, and that's called an endothermic process. As you maybe guessed by the color of the pen that I'm using right now, this process feels cool. An exothermic process is exactly the opposite. This happens here, the compound will form and energy will be released. When energy is released, it's released out back to the system, and it's going to feel warm. Now that's when we put together an ionic compound. When we break apart an ionic compound, we have to break apart that rigid structure. And this breaking apart of the rigid structure is called the lattice energy. And by definition, this is the energy required or needed to separate, and here comes a new science term for you, separate 1 mole, and that's an amount, we're going to learn about that one down the road, 1 mole of ions in an ionic compound. All right, so down here in the picture, what we see is we have an ionic compound, sodium chloride. And in order to break this apart, delta H, that's your heat energy, must be added in to break it up into the component ions. This would be 787 kilojoules per mole, happens to be the lattice energy for sodium chloride. Now the relationship that needs to be understood with lattice energy is that the greater the charges of the ions, the greater the lattice energy. So if you have, for example, +2 magnesium and -2 oxygen bonded together in a lattice, it's going to have a greater amount of lattice energy or a higher number of kilojoules required to break apart 1 mole than, say, the +1 and -1 charge of chlorine. Now, when we talk about ionic compounds, we don't talk about ionic compounds as being a molecule. Molecule is reserved for something else. And we certainly can't call it an atom because it's multiple atoms brought together. So when we talk about an ionic compound is expressed in what we call a formula unit. Okay, an ionic compound simplest ratio representative unit. This is one of those terms we're not going to abbreviate too much for obvious reasons. I don't want to be grading a bunch of papers and finding a bunch of abbreviated forms of those two words together. Now, when we're talking about a formula unit, we're talking about the complete thing. Okay, we're talking about NaCl. NaCl is the formula unit of sodium chloride. Okay, because we have a metal mixed with a nonmetal, we know that we're talking about an ionic compound, something that has charges. The net charge is always equal to 0. And the simplest form, again, is called... There are two different types of ions that make up the ionic compounds that we've been referring to. Monatomic ions and polyatomic. Now, monatomic just means one atom. And that's what we've been talking about so far to this point. As I was saying, monatomic ions are made up of only one atom, and we've talked about those before. The chart down below and the chart down at the right give you some of the most common monatomic ions. Note again that the group 1A are always plus 1, 2A plus 2. And those are the common ones, those are the normal ones. And we talked about 5A being minus 3, 6A being minus 2, 7A being minus 1. In a previous video, we actually showed where we're going to have variable charges. The chart over here at the right gives you some of those variable charges. These must be brought to memory, okay? And these are the most common ones that we need to talk about. We've got iron, copper, mercury, tin, lead, and cobalt. Now, aluminum follows a regular trend, so we're not going to be worrying too much about that one. Zinc and silver, however, even though they are transition metals, they always take the same charge. Plus 2 for zinc and plus 1 for silver. Now, when we're talking about the ionic compound formula, we have to look at a couple of the different parts. Note that overall, we have 0 charge. The net charge is 0. We have one part here, and we have one part here, and we have a subscript in between. The cation is always going to be listed first. And the number that follows the cation there, 2, indicates how many of those particular atoms we have. That's going to be followed by the anion. Now, because there's no number that follows the anion, we're going to assume it's 1. Now, the reason I see overall region these things come together is that the charges have to cancel out. And the reason that we have 2 sodiums in this case and 1 oxygen is that sodium takes a plus 1 charge. Oxygen takes a minus 2 charge. In order for them to cancel out, we must have 2 sodiums and 1 oxygen. The final part that we'll talk about, we're going to practice this a great deal more, is polyatomic ions. Now, polyatomic simply means that we're going to have multiple atoms. So, more than one atom making up an ion. So, one example that we have is down here to the right. This is the ion nitrate. Nitrogen bonded with 3 oxygens will have a -1 charge. Now, whenever we want multiple polyatomic ions, we must place that whole polyatomic ion in parentheses. So in order to get the charge to cancel out on this particular formula, we'll have to have 2 nitrates. And to show that we have 2 nitrates, we're going to put all of nitrate in parentheses and then close it off and put the number 2. That's saying that I have 2 of everything that's on the inside, so 2 times my -1 gives you a total negative charge of -2, which cancels with the positive 2 charge of calcium to give a net charge of 0. The last little bit in this lesson is an oxyacid, and we're really just going to define this term. An oxyion, rather, is going to be any polyatomic ion with oxygen in it. And there's lots of different examples of oxyions out there. We have the chlorates and chlorites, we have bromates and bromites, and we have nitrates, and we have sulfates and sulfites, we have phosphates, and so forth and so on. And we're going to talk a great deal about these more in the future. That's all we have about ionic compounds and properties. We'll talk more about this in class.